All right, guys, we'll get started. Welcome to BrainX Community Live for the April 2025 session. And we have some really exciting presentations coming up in a few moments. Again, thank you for joining us on this beautiful day. Many of you I see might be new to our live events. So I'll just do a brief intro of BrainX community. We started this community more than 6 years ago with the idea that we need to have a platform for machine learning in healthcare for good. It has grown to have more than 6,000 members across the world, a very diverse group with clinicians, with different healthcare professionals, with AI experts, venture capitalists, investors, everybody very excited to learn about AI in healthcare and opportunities for collaboration. We have a very active LinkedIn group where we share a lot of scientific material, content, and upcoming events. So please join us. It goes with the name of BrainX Community. It already has almost 3,500 members in there. And briefly, I will go through our website, brainxai.org or brainxcommunity.com, where you can find a whole host of resources over there. And we do this monthly webinar series where we showcase the work of some amazing researchers, innovators, developers who have worked in this space. So really excited to share some of this content. So if you go to our homepage, you will find a lot of updates right over there. So you can pick up on the latest updates there. Our Connect segment features these monthly webinars, so you can learn about what's coming up next. If you miss it, it's there on our YouTube channel. So we record it and we post it on our YouTube channel, so you can watch it later. So please subscribe. Again, LinkedIn is the place where we stay connected on social media. So please join our BrainX community group over there and share your scientific work or collaboration opportunities over there. That's what that group is meant for. We provide a whole host of learning resources. So we curate the publications that we are pretty much drowning in these days. So we present a curated list of articles. You can go to our Learn section on our website. We provide you links to these prominent publications. They're categorized based on healthcare specialties so that you can look into the healthcare specialty of your choice. Similarly, a lot of you are looking for data. So we provide the largest repository of links to open source data sets. We also categorize them for different healthcare specialties, and we did add LLM as a category two last year, so that if you're looking for LLM data sets then related to healthcare, then you can find them over there. So we provide information, and you can go to the directly to the links from here and get more information and hopefully use them for some of your research or development work. We also have our podcast series where we feature prominent or eminent researchers, developers, innovators from across the world. You can learn about their journeys, why they got into AI in healthcare, what excites them, and what's their future outlook. So learn about it directly from them, and hopefully they inspire you. And of course, we want to connect with each other at these meetings and conferences. So if you are looking for AI and healthcare focused conferences, we provide a curated list in the conferences section of our website, and you can find them over there so that we can hopefully connect in the future and work together. A book that we published about strategies for AI in healthcare is now available on Amazon, so you can learn about different strategies. It's a really hot topic. And going to something that we found really amazing in our year-end review publication from BrainX AI Research. This is for the first time, having done this year-end review research for the since 2019, we found that large language models were the most used models amongst the mature publications in 2024. And that's very exciting. Previously, it always used to be deep learning, deep learning, deep learning, pretty much convolutional neural networks with one type of data. And as you can imagine, it was image based data. For the first time amongst the mature publications, and you can read our year in review available through our website, first time large language models were the top research mature models in healthcare. And with that, we also saw it across different healthcare specialties in the same publication. So it's not just one particular specialty trying to do it. Rather, what we found was that education as a specialty, if you were to categorize it as a specialty, or administrative tasks, or if you were to categorize as a specialty, were some of the key areas where people were looking to use LLMs beyond the clinical needs or beyond the clinical space. So, really exciting work going on in this space. But what's also amazing are the next category of models that are coming that I'm very excited to introduce the two Dileeps that I know of, prolific innovators, amazing guys, and you can read all about them. They started Cloudphysician. Dileep Raman is the chief of healthcare at Cloudphysician, and Dileep Unnikrishnan is the technical lead at Cloudphysician. They have done some amazing job. I met them recently at SCCM. I've known them for a long time. We had featured them previously too, but their amazing innovation captured my imagination. Now, one key thing that I find them differentiated from a lot of other researchers or innovators or developers, in my opinion, is a lot of them are trying to apply technology to discover or solve a problem. The Dileeps are actually trying to solve a problem using technology, which is the right way to do it. So, with that, I will welcome them to talk to us about the amazing application of AI, especially the vision models and the agentic AI that they're working on, and let them take it from here. So, Dileep, I'm going to hand it over to you.
Thanks, Piyush. Yeah, we are the two Dileeps. There are also two Dhruvs in our company. My co-founder is also a doc. His name is Dhruv Joshi, and our chief AI officer is Dhruv Sood. So yeah,
That's by design.
Yeah, that's by design. We're limited on the names that we use. So, but thanks for the warm introduction. And yeah, we hope to share some things that you guys might find interesting. And we're also looking at how the space is maturing. And let me just perhaps share my screen and get started, if that's okay, Piyush.
Yes, please do.
Okay. So we'll split this talk into two sets. One is to just discuss some of the real world applications and how we are deploying this at the bedside, similar to what Piyush was talking about. And the second would be more about some of the technical details. I'm sure you guys will have questions and take that discussion up with Dileep, the other Dileep, who actually is knee deep in all of this, and we can discuss both pieces in as much detail as you guys like. But yeah, we think that video AI is probably the next big leap in patient safety. Imagine cameras in the ICUs or in even a med surge setting that are tirelessly watching patients. There are a lot of things that we need to talk about from a deployment perspective, which touches upon regulation and risk and how you assess that. But if you look at it from purely the lens of patient safety, ambient technologies are likely to make the biggest paradigm dent in patient safety that we have seen thus far, simply because of the fact that devices, when they're plugged into patient physiology, have their limits, and when you give that the gift of sight, things change. So that's what a VLM is. It gives an LLM the gift of sight. So to put it in just a very simple sentence, but think about it as a central LLM that's sort of your policeman LLM that then gets multimodal input into it. The inputs can be in the form of EHR data, or from devices around it, which is fairly commonplace and people have access to that. But we think that without video, that's about 65-70% of the data story of what's happening in the room. And when you give the additional input of video, then you can actually derive more comprehensive assessments and insights about what's happening to the patient. So one of the themes that we talk about increasingly in our company and how we think about product development is that there are a lot of AI tools that look at predictive analytics, and looking at seeing how the patient's journey is going to mature. And one of the challenges that's been talked about on this forum as well previously is that data quality is always suspect. And that's what we are trying to focus on right now. Is let's just focus on analyzing the present as much as we can, as deeply as we can, and moving from a token predictor, adding a layer of video to that, and then leveraging the existing reasoning engines that are already there, is what we look at as the next phase in how we can analyze the present more deeply. Meaning, add real-time video to the analysis of the present, in addition to your devices and EHR data or lab data or notes data that you already have. That's how we are looking at this. And while we think we're doing something exciting, but there are other folks working on this as well. There are few teams globally that are looking at the ambient video space. This is the group out of Stanford. Fei Li's team has published a lot of research on this. This is one of the more recent publications, and they're looking at this is in Nature, I think, a couple of years ago, where they were looking at shining a light on dark areas of ORs and ICUs, specifically high acuity settings, where they wanted to see patient interactions and caregiver interactions. So if a wheelchair is being rolled, how does the patient workflow and the journey change if they're on a wheelchair versus ambulating through the hospital? Again, those are just low acuity patient transit examples, but examples are also there inside the OR, how the clinician or the surgeon or the nurses interact with various devices on the OR table. And this is another active area of research that is happening. Another paper that they published was looking at hours of footage in the ICU, and wanted to look at a behavioral atlas of what goes on around the patient bed. You can see this little graphic on the side. If you look at the paper, you'll see some of the imagery that they're looking at, where they're trying to classify all the things that are around the patient. And you can imagine there's a lot of insight that you can draw from something like this, right? What equipment at the bedside was touched? Was infection control a part of the workflow? You can actually automate some of your infection control audits completely just based on video data. The possibilities are actually pretty deep, and this is an increasingly active area of research, right? So you have LLMs, but now there are some researchers talking about, have LLMs plateaued? Do we need to move on to other avenues? Jan LeCun himself has talked about this very publicly most recently, and we feel that this is the next layer. And the authors from the same NEJM study actually call this out. What they're saying is, sure, we've done a proof of concept, we've done analysis of an initial video stream, but where that is going to hit reality is, how do you take diverse data sets from other settings and then refine these models? And one thing that we feel as a group at Cloudphysician is that this is where our work sort of begins, because in our team and in our R&D base, we have hundreds of cameras deployed in multiple ICUs. So the exact kind of diverse settings that the authors are talking about to real world test these models is what we do. So let's look at this example of, this is an actor patient sitting on the bed. The model can actively detect grimacing, writhing movements of the neck, whether they're uncomfortable, call it out as a pain score, and then alert the clinician if it's needed. Now, yes, alerts can be pretty painful if you have a lot of them. But what we think is that ideally this should be baked into a preset note or a flow sheet automatically. And I was at HIMSS recently, and Epic is actually doing some work on this, where they're trying to create an ambient workflow for nurse charting. But that nurse charting is going to require some input. It cannot always be audio, and audio sometimes can be cumbersome. And what we think is a agentic video input would actually be the right step forward. So similarly, if you look at pain and then move on to restlessness, without the grimacing, it would just look at body limb movement. Are they sitting put in their position or wanting to move around a lot? You would just send a flag. But rather than an alert, let's try and see if we can bake this into a workflow. And there is some work on this. Other groups are actually looking at if you can detect delirium, or if you can detect any activity that correlates with delirium. That would be important. And just from a clinical relevance perspective, many of the times in the ICU, if a clinician wants the sedation at a certain level, we go by a score called the RAS score. You want a RAS score of, let's say, 0 or -1. What ends up happening is that oftentimes patients are over sedated. They may be a -3 when you actually go out and measure that. And what we want to do with some of these agents is make sure that we're able to tell the nurse that, this patient may actually be a -3 or a -4 and more deeply sedated than they need to be, and then pick up these movement clues that you can from an ambient video interface saying that, look, this patient is likely over sedated, under sedated, or adequately sedated. So you can condense the 10-point RAS score into a very practical 3-point score, which we call visual RAS. This has not been validated. This is an active area of research. But what we're trying to say is a visual RAS from a computer vision system, how does that correlate to a 10-point RAS score? And then can you build a workflow that reduces the level of sedation for a patient, and then hopefully a less delirium and a length of stay related outcome from that. So again, similar to that, from sedation, you can look at respiratory distress. So here what the model is looking at is it can look at neck movements, accessory muscles of respiration, the depth of the chest movement. And this is an adult patient. We have a patent on the neonatal respiratory rate detection that just uses a Fourier transform on the video that you're seeing and can visually measure the respiratory rate without manual intervention. Importantly, in neonates, respiratory rate fluctuates over the course of a minute. So unless you're watching the baby for the entire minute and manually counting the rate, it's very hard. That's why we built the model. But that's the use case where a monotonous minute of a clinician's time can just be automated from a video agent like this. So that was the examples of what we would do in a high acuity setting. But moving to a more lower to medium acuity setting, this is a use case that we're actively working on right now, which is reducing the cognitive load on a virtual sitter. So typically a virtual sitter would be seeing 6 screens or 12 screens, and just like you have all these Zoom tiles in front of you right now, imagine 10 tiles of individual patients in a med-surg room. That's very hard for a human to keep track of. And this is an 8-hour or a 12-hour shift, and they're supposed to pick up early warning signs of a fall. And that's entirely depending on their cognitive load and their attention that they're actually keeping on their eyes on these 6 or 8 tiles that are in front of them. And that's hard. So what we wanted to do was to see if we can automate that. So again, the same video AI framework is in play, and you can see as the patient sits up, there's a visual alert saying that the patient has moved from a sitting to lying position, or one of the limbs have left the bed perimeter, giving them a warning signal. So just allowing them to scale to 24 tiles in itself is actually a win. And this is all real time. The processing is happening real time. If the patient lays back down, the alert goes away. If one arm is outside the perimeter, or if they change from supine to prone, that alert is also sent to the virtual sitter, who is then able to be more productive rather than toggling through 6 tiles at any given point in time. Now, I'll just go to maybe further down the video. You can zoom in and see what's happening, and you can see individual alerts pop up. So if the rails go down in real time, the railing down alert is actually visible. And then we can actually go to something called a spotlight view, where once you snooze the alarm, for example, let me just go to that view here and just show you. So we're on spotlight view right now. And if the patient who's lying down now sits up, you get an alert. It continues to watch for behavior. And if it stays high risk, it actually moves the entire screen to a more focused view. And then if the patient is agitated, it stays on that view. And if it's showing any new alerts like the arm or leg moving out, it'll tell you that that's what's happening. But if he goes back to lie down and is again low risk, it'll go back to that ambient view where it's all low risk and there's no call to action there. So again, just some examples of what some of these automated workflows do. Now here, there's no AI on the front end. It's just a UI and a UX that's friendly for the user. The artificial intelligence and the video analytics is happening at the background. So what we want to do going beyond, and this is all going to take a lot of R&D and testing. What we just showed you was built over the last 4 to 6 weeks. And we have a 510K exemption registered with the FDA. But what we're showing here right now is the more high acuity use cases, right? So you can look at ventilator waveforms and how the patient interacts with them. A hot area of research, trying to reduce patient harm. Are they getting high tidal volumes? Because the patient can get injured with tidal volumes in between the time that the RT or the nurse is in the room, which can be a couple of hours easily, right? And that's what we're trying to pick up in an ambient fashion, and then create a dashboard for a quality manager or someone from the respiratory institute who would want to make sure that these parameters are being monitored and are in check. Similarly, if you're looking at other themes, which is along the lines of pressure ulcer, bundle compliance, these are things that ambient video can actually help clinicians and nurses with dramatically to reduce their workflow and time that they need for that. This is a video. Let me see, can you hear the audio? Yeah. This is what we showcased at SECM. So I'll just share it with the group here.
Administer nebulized albuterol to the patient and start NIV with an EPAP of 8 and IPAP of 14. Let's also get an ABG and a ProBNP and stop all IV fluids now.
So this was an example of how we can potentially use some of these agents and build it into the workflow. So we wanted to see how a nurse or a clinician at the bedside could use some of this. You saw the virtual sitter workflow as well. So these are actual examples of how it needs to be plugged into the workflow. Because I think the most important thing is actually how the workflow is going to function. Because I think a lot of the AI tools or agents that we build don't fit into the workflows right. And in this case, we would actually customize that a lot with the team that we are speaking to, because the workflows are so varied and heterogeneous that you can't design one size that fits all. So, and that's something that we are really focused on, is that we can certainly build the agents. We have the critical care use cases that we can develop, but working with colleagues and actually people who are in at the bedside and plugging to that workflow is actually critical. So I think all the other things that are there on this slide are important, but I think probably the most important one is the plugging into workflows problem, because that's easier said than done. It often requires a lot of testing, working with the bedside, plenty of trials before you actually see the outcome you want. So I'll hand it to Dileep here, the other Dileep, maybe to talk a little bit about some of the technical stuff that goes behind this. And yeah, thanks everyone for listening. Happy to take questions at the end.
Uh, okay, thanks, DR. So I'm the other Dileep in the company. So I'll be talking a little bit about the back-end workings of what Dileep Raman showed, and maybe reflect a little bit about the broader picture on how the ecosystem is evolving. So if you're a 90s boy like me, so you might have seen the evolution of computing over the years. So in my childhood and teenage years, computing was mostly for repetitive tasks that needed a lot of accuracy, and all the creative works, writing poems, drawing images, those were like mostly for humans. But over the last half decade or so, things have dramatically changed. So can you move to the next slide? I don't have the, yeah. Okay, so before going into LLMs and VLMs, just wanted to take a moment to go to the history of how ML has evolved over years. So, I my timeline here starts in the 1990s, but actually it goes beyond to about 1960s. So 1960s were the first multi-layer perceptrons, researchers developed it, which is the most primordial form of neural networks. Then 1986, I think, was Geoffrey Hinton developed the back propagation algorithm, which is behind the training of all neural networks that we have right now. And he got the Nobel Prize for Physics last year. And then, in 1990s, 97, the RNN, recurrent neural networks, and the LSTM, long short-term memory neural networks were created. And these were mostly, with this, machines got the ability to process sequential data, especially time series data. 2011 was when word embeddings were discovered, with which machines got the ability to uh, uh, process and understand the meanings of words in the way humans understand it. 2017, attention got discovered, in the seminal paper by Google Deep Brain researchers. Attention is all we need. So attention, with attention, machines got the ability to understand the main concepts of large corpuses of text, and trace them throughout the length of that text. And this is with this, there were there was a crop of newer models called transformer models, and that's what the precursor of all, that got iteratively improved over the years. So in 2020, there were initial uh, signs of GPT-3, like some OpenAI newspaper articles, publications, and all that. 3.5 got released in 2022. I'm sure everyone must remember that point. And a couple of points after that would be the release of open source large language models by Meta Labs, Llama models. And probably you can put the reasoning models that got released last year also. So yeah, next slide. Yeah. Okay, so with that said, let's reflect a little bit on what machines used to do, what machines can do right now, and what machines will be able to do in future. Right. So here I've listed a few things which, from left to right, is in the order of hardest to easiest that can be done by machines. Right. So the feeling and subjectivity would be the hardest. You can go, yeah, feeling and subjectivity would be the hardest, and the logic and heuristics reasoning, that would be the probably the easiest. So um, to put this in human language, like if you look at a rainbow, right, the feeling and the awe and inspiration that you feel by looking at a rainbow, that's very hard for, that cannot be, I mean, at least in the recent future, can't be done by machines. um, like the light reflected from the water droplets that cause the rainbow, that's harder but still doable by machines with an image sensor or whatever. If you describe how the rainbow looks like to a machine, and process it through GPT, that's even easier. Heuristic and logic, like you describe the math behind it, physics behind it, that's the easiest part, right? So pre GPT machines were mostly limited to the heuristics and logic part of it. One slide more, yeah. So with the GPT, it opened the whole realm of natural language. All the human information in natural language got processed and condensed, and uh, was made accessible through the set of transformer models in the GPT era, right? So how did that change the software development, the general ecosystem, right? Can you go to the next slide? Yeah. So there are I mean, this part is a little bit contentious. I am sure there are much more knowledgeable folks in the audience, but this is just my opinion from my experience. So the old paradigm was you have a interface and you interact through code to a software stack which does all the compute, and you get the output through the interface. This was the old paradigm, and the entire software stack used to be developed and maintained by an army of engineers. All right. Next slide, please. Yeah. With the new paradigm that I'm increasingly seeing is that you have an interface which is mostly worked through natural language, and the entire compute happens in an LLM, and you get the output through a natural language also. To give you an example, at Cloudphysician, we used to, convert all our written doctor's note into ICD codes and store it for better analytics, right? So pre-GPT, it was like a module of thousands of lines of code that used to do natural language processing, semantic analysis, negation detection, all those stuff. And uh, post GPT, this got condensed down to one single prompt that makes a call to an LLM, gets the ICD code back and stores it. That's it. So increasingly, more and more tasks that used to need a lot of compute through a software stack is being replaced by LLM. And also, I mean, in my opinion, every compute that you see, like in your Mac OS, Windows OS, being replaced by an LLM is only being limited by two things. One is the fidelity of the LLM, and the second is the compute expense, right? So both are being addressed and going exponentially, like one is exponentially increasing and other is exponentially decreasing. So that's the sort of paradigm change that we are seeing in the field. So what does, with that being said, what does VLMs bring into the table, right? So it takes the whole thing one step further, which is like uh, increasing the accessibility of information to the LLMs, uh, to the realm of senses, like your video, light, audio, or all that is going to be like all that missing information is now accessible for your LLMs. All right. Uh, okay, so VLMs in healthcare setting. So coming to the back end behind what we are researching and developing. So in the setting of healthcare, you have your patient video feed, which is being converted into a scene description in the context of a user prompt. And this scene description is being used for downstream processing of all the alerts that can be generated, orders that can be placed, for documentation, audits, retrospective audits. And then there is an uh, optional step of video storage for retrospective review. So like, to give you an example, if you are a emergency room and you are storing your monthly video stream along with the scene description, you will be able to query the scenes out that you need. Like, for example, if you want to see all the pediatric intubations last month, you could just write a query saying, like, show me all the pediatric intubations in the last 1 month, and it will just pull all those scenes out. Yeah, next slide. Yeah, some of the frequent questions that we get, like, which are the models that you use, like, so it could be like, there are a lot of open, I mean, not a lot, but there are a few open source models available, like Quen is one, then DeepSeek is also multi-modal. You could use these models and fine tune them further. You could also, like, there are a crop of deep learning models that are available in Hugging Face repository, so those can be used. um, where does the compute happen? It can happen anywhere. If you set up a server in your office, the compute can happen there. For most of our use cases, we do the compute on the cloud. What can the models pick up? In our experience, anything that can be that's discernible with human eye can be uh, theoretically picked up using these models. How much does it cost? Generally, video processing is compute expensive, but the good thing is that the cost is going down over the years. The compute cost is getting down year after year. So that's a good thing. Yeah. So I'm happy to take any questions that you might have.
Thank you, Dileep. This was fascinating and this was awesome. Like every time I talk to you or watch some of your presentations, I get like so inspired. I really want some of these technologies at better. Dileep, I learned you say like Dileep R and Dileep U. Maybe that's how I'm going to differentiate it. So, Dileep R, something that resonates very closely is the focus on quality and patient safety. That is what inspired me to look into AI as a solution for healthcare problems, and I think that focus is immense. And Dilip, it's fascinating to see the journey of these models. I remember same things that you encountered. It used to be CNNs and those RNNs and those some very basic NLP tools and some LDAs that we were using, and all of a sudden I remember I was doing the stationary biking and I was taking this Transformers course. And I texted my team and I said, like, this is really going to transform everything. I think that turned out to be right. So, uh, amazing capabilities. But I want to go back to something that, actually, first, a word of caution for all the people who are watching this. Don't try to do this at home. These people are very experienced. They have been at it for quite some time. I think the presentations talk about it themselves. So, the first question that people struggle with, beyond the model issues and other things, is the data, the healthcare data part of it, right? So again, some of these models probably are easier to train in many ways because you don't have to pre-train them. You can just, in technical terms, either give them some examples, like some short trainings for those who do this technical work, or they could be probably fine-tuned on less amount of data for a particular task to be done. What's your approach or your team's approach to developing these models for healthcare on these unique tasks, and the data challenges there?
Yeah. So a lot of these can be. So I'll talk a little bit about the stepwise approach here. First, I'll see if a lot of the problems can be addressed through prompt engineering and sequentially addressing it, like you give it one prompt, get some information and pass that information with something else to another prompt. Like, prompt engineering is the first way to do it, and the cheapest way to do it. And if prompt engineering is absolutely not going to work, then you go into the fine tuning aspect of it. But fine tuning is pretty expensive right now. So and in our experience, most of the cases are manageable through prompt engineering.
All right, I'm going to take some of the participant questions over here, and thank you for the active participation here. So some incredible feedback and questions that we get over here. This one comes from one of the participants, Anurag Saxena. He says, are you able to augment video processing along the real-time series data? So real-time series data coming from the devices the patients are connected to, or are you just relying 100% on the video feedback?
Yeah, I can take that question. Both Dileep and I were working on this problem statement because it came from hospital systems that we are actively talking to. It's a great question, right? Do you sync the time series data coming from the bedside monitor, which will have different paper speeds and different stream rates and sampling rates? The point is that we can, but when we were doing R&D on this, we just relied on video alone. See, one of the things that prompted us was to be a little skeuomorphic, right? Which is, we wanted to mimic how a bedside doctor or nurse functions. They don't have the monitor plugged into their brain, through a neural link or a time series map like that. They're analyzing the patient video as it's unfolding in front of them, and that is what we wanted to try and see if we can mimic. And then once you have the rough timestamp, you can always go back and parse the data from the device, which is where that multimodal point comes in. So the policeman LLM is sort of going to coordinate that activity like an orchestra, where the video data is coming in and says, okay, this second timestamp, between this second and this timestamp, the patient had respiratory distress. Now let me go look and see what the monitor was saying at that point in time. So we haven't interfaced it exactly. We're actually taking the quote unquote human approach to see how that would work. Again, active area of research. This is the approach we are trying, simply because that's most similar to what the real world functions like. But is it possible? Yeah, it's absolutely possible. If you this is a problem statement that has been solved in different industries. Most common industry where this is solved is the music industry, where you have something called as a MIDI, a music interface, digital interface, where the time signature of different instruments is actually mapped to a common framework. So we're not doing that right now, but plenty of stuff exists on the outside to map it. The other interesting thing is that you may not be able to map it with the exact same sampling rate, because your video frequency would be 20 frames per second or 18 or 24, whereas the sampling frequency of some of your devices may be much higher or much lower. So you'll have to find a common middle where the output matches the time signature. But we're taking a more real world play on it, starting with the video and then going back and querying what the data was like.
That's great. And thank you for responding to that. The next one that I have is from Osborne Pereira. Please pardon me if I'm mispronouncing your name incorrectly. And I'm going to try to condense it into a smaller form. Like, how do you overcome challenges such as like hallucinations or misrepresentations or misidentification or LLMs not accurately representing the ground truth?
Yeah, do you want to take that? Part of it is actually tuning and training and prompt engineering that you already addressed. But
Yeah. We so it can be addressed in multiple ways. One is like passing it to multiple LLMs in parallel and seeing taking a vote. That's one approach. And the second approach would be to um, like so to give you one example. So like if we are monitoring sedation, which needs to be done only like once in every 10 minutes, right? So you can create a dot plot on of the RAS score, minute by minutes RAS score, and then see the trends in the, then do a statistical analysis on that, and say like anything that can be made into a score, you can increase the frequency of sampling and then look at the trends in that, right? So there are approaches to address the hallucination problem. Dr, go ahead.
yeah, one other point here is, this is a pretty new area of research, right? So we're not taking the human in the loop out. We're going to keep the human in the loop for the foreseeable future, simply because of the fact that this is just cutting edge, right? We're going to have to figure this out over time as we tune the models, and those models get better over time. So all the problems that you're highlighting, like hardware malfunction, there's an obstruction, we faced that while we were testing this model. So for example, if we take a bed sheet that's the skin color and put it on the actor, we do get a hallucinated output. So we need to figure out how we can train the model to avoid that, or at least send an alert saying, hey, there seems to be some obstruction, I can't see the arm or the leg very clearly, or the bed sheet is the color of the skin and therefore causing some drop in the accuracy of the model. So these are all very real problems that, like Piyush was saying, right? don't try this at home sort of means that you're going to see these challenges. And we did see a lot of these challenges, and we continue to see them. So it's going to take lots of time and data sets that will help tune this, which is where the R&D team comes into play, where we have access to terabytes of videos that we have to leverage over time. So this is not going to get fixed in a day, but it is going to take a lot of training and tweaking over time so that this gets better.
Yeah, I think this is such an evolving space. It's incredible. Some of the tools are evolving, the models are evolving. You look at some of the leaderboards; they're very competitive in terms of the model outputs. So I agree, like that. This is, and some of the frameworks to use them are evolving very quickly too. I just my personal experience. I just finished this course on deep learning AI. Deep learning AI has remarkable, unbelievably good courses on evaluation of agentic AI. That's something that BrainX AI research is very, very focused on. And it's not that straightforward. It is a complex task to undertake. And when you design pipelines, it can be challenging to do that. But I think group like yours are at the forefront in doing this evaluation and then doing continuous improvement. That's what that course talked about too. So it's not that you just create a solution one time and apply it. It doesn't happen in real life either, right? So that's why when I did quality improvement work and led our team, a lot of our work was continuous improvement, even in real life, because we looked at the data and we said, well, okay, we need to improve our extubation scores, or we need to do more spontaneous breathing trials, or our tidal volumes are not good, or the charting for pain scores is not accurate. It's always an iterative process. So I don't expect it to be different in AI space either. And also sometimes the question of what's optimal, right? So ideally, I would want accuracy and everything to be 100%, but what is optimal and acceptable is another question. So if our performance in real life is 85%, is anything above 85% okay in terms of performance from AI? Or sometimes our expectations are too high because a lot of engineers want it to be 100%, 98% or so. So I think those standards and those benchmarks for performance become important too. But thank you for explaining that so well. I'm going to take the next question. It's from Angeline, and I think she's, if I'm getting it right, I think she's talking about the unique challenge that she faces. That is her space in the ER. So how do you use something that is trained for maybe one work area for one task and then develop something that is for another area or another task? So is there an approach to scale it or to transform it to something different?
Yeah, I think,
Yeah,
Dileep, you can also take this. I think this
yeah,
is
yeah.
just model framework.
I mean, my response is that like we are not at the point of scaling yet. Um, yeah, but DR, go ahead.
Yeah, it's more, see, this is a unique use case around the ER. And some of the models, I mean, we've just tested it where it can detect other people in the patient's vicinity. So it's basically an interaction sort of a test that we were looking at, whether if you have a patient on the bed, who else is walking past the bed? Like, is it a nurse? Is it a doctor? And actually, the LLM is pretty good at picking some of that as it's looking at the video play out in real time. But in this particular case, they want to look and see if you can pick up, aggressive behavior, for example, in the ER or a busy ER. Haven't tested it. We haven't looked at that use case, but that is exactly the kind of stuff that these video models can do. They can look at that, and I think it's just a matter of what our imagination wants to solve. And if you have the base data set for that and tune it to that, it's certainly possible. This is not an impossible thing. And frankly, I would actually not be surprised if some of these people models already exist in the security industry. That's the closest parallel that would want to look at interpersonal interaction between large to medium sized groups of people. So I think that problem just needs to be adapted to a closed room ER setting. But detecting people and interactions of people and their body movements and their levels of aggression, this is, I think, a solved problem.
Yeah, that's a great thought. I picked up on that, Dilip. You look at other industries too. Just like, when we
Yeah.
do research, we are looking at different healthcare specialties. There is a lot to be learned and gained from looking at other industries. But I think there was one a question or a comment that was hidden in the chat that I want to follow up on, which becomes a common legal question about the privacy aspects of this. People are always concerned about cameras
Yeah.
and the privacy aspects of this. So, what have been some of the challenges that you faced over there, and how have you overcome them, considering that the laws and regulations are different in different places?
Yeah, there's a that's an interesting problem, but I view it as a transitional step, in the sense that just like you had the same problem in driverless cars, and over time driverless cars have less accidents, and people are worried about what a driverless car would do. Similarly, I think what you would see is that it's a trade-off between having a camera and a higher level of patient safety over time, and then seeing how you need new guardrails to make this work. And I'll give you an example. So the same Stanford group, in their earlier paper, looked at masking. So the video is still being recorded, but the identifying features of the face are masked. So you can have this masking that's running retroactively. So, for example, some of these agents or these videos will never be seen by humans. And what you would have is just videos that are recorded and masked. And if a certified person wants to see them, then they sort of break the glass ceiling, and just like you access an EMR, you're going to be able to see that video. But that's the entire framework that needs to be built out when some of this tech comes in. You're never going to be in a situation where the legal framework is done and then you can innovate. It's always going to be the other way around. So I think one is demonstrating that patient safety is actually better, and so this is a strong area of outcomes research that needs to come out of this. And then once you have that benchmark, then you'll see, okay, then we have some form of consenting that comes into play. How long do you store the video? Is it 7 days time to discharge, or erased every day? Every organization is actually thinking about these same problem statements and how to address them. But there are tech solutions as well that can safeguard privacy, like I was sharing with you, the automated video masking feature that can be layered on what you're building.
Yeah, and also one parallel that I draw here is voice activation, like voice commands, Alexa in your living room, right? Like, when Alexa came out, there were a lot of concerns. Oh, yeah, there is a machine listening to everything that I talk at my living room all the time. But over the years, people got used to it, and now it's pretty much the standard. So like that, DR just said, innovation precedes regulation. So yeah.
Yeah, and I think that's the other point that Pablo is asking, is that's exactly what's needed. We would want to look at multi centric research between teams on how to take this to the bedside. So lots of organizations that we know already have cameras that are in the rooms, but they're either sitting idle or they're being used episodically. But what they actually are is that they are a powerful conduit to what can happen in the future, and that needs to be leveraged. So the research partnership, for example, would be like, okay, this is the problem that we want to solve. We have a high rate of, I don't know, self extubations. So then we say, okay, we'll create a agentic framework that looks at tube disconnection, sedation, patient activity, patient movement, and then cross reference that with EMR data on what type of sedatives are being used, and then draw out that as a research output that would then have a solution that's tailored to a valid clinical problem that's there at the bedside. But yeah, that's how we would want to work with organizations.
Yeah, no, I think what I'm capturing in the chat is all the excitement. Somebody talking about like I want to use it in ER. That's how I
Yeah.
look at it. Somebody saying like, how do I use it in a small hospital where the resources might be limited? And somebody's saying like, okay, how do I do research? This is all the excitement that the two Dileeps, your organization has built, and I wanted to capture it over here and bring it to people through this. So there are so many use cases. I'm sure after this talk, everybody is going to be thinking about, oh, we could use it for this or that. But the amazing aspect of the journey that Dileep you had also stated was previously a lot of these models were very narrow network, very task oriented, took forever to build and everything. I think the development of foundational model is truly transformational because for a lot, as you said, either through prompts or through few short learning examples or much less compute and data, you can train these models to do a lot more. And the multimodality aspect of that, like we couldn't imagine this. Remember, like 5 years ago, we were still trying to deal with the CSV files and trying to do with 20 columns and 600 rows. And all of a sudden, we're talking about video, audio, and the waveform and numerical data, text data combined. So it's just the immense possibilities that are there. So I would ask all the people who are watching this to think about all these things and reach out to Cloudphysician. They're an amazing group. They're doing some amazing amount of work. And I think the application space is huge to collaborate and to bring it to life and all. So I do see a few other great comments over here, but I think I'm going to end it over here. Once again, thank you for joining us for this amazing session. This was recorded, will be available on our YouTube channel for viewing later on. And please follow us on a whole host of different mediums. We have our website. You can join our Substack newsletter over there. Follow our LinkedIn group. You can watch these live sessions. Join us for these for exciting conversations. Follow our YouTube channel, podcast series, or email me so that we can collaborate. But thank you, Dileep. Thank you, Dhruv's in the background. Thank you, Cloudphysician, for doing this. Thank you to all the participants. An amazing presentation. So till next time, have a good day.